Good morning, students. So, in the last lecture, we have discussed the liquid dosage forms, in which first there were the monophasic liquid dosage forms, which consist of solutions. So, solutions are generally the clear solution. Solutions are considered to be the clear solutions because there are no insoluble particulates in them. However, in biphasic solution forms, there are two types of biphasic solution forms. There are suspensions and emulsions. The solid particle, the insoluble particulate, when dispersed in water, is called suspension, and when two immiscible liquids mix together, they form emulsions. The two immiscible liquids are the most common example of two immiscible liquids are oils and waters, or you can say the petrol and water. These types of, when these types of two solutions are mixed together to form a homogeneous solution, this is called emulsion. Okay, so in this type of emulsion, first we will start with the introduction. So emulsions are thermodynamically unstable liquid dosage form preparations consisting of two immiscible liquid dispersed with the help of an emulsifying agent. Okay, so in the definition, as we say, they are thermodynamically unstable. That means upon the application of heat, the emulsion will crack, the phase separation will occur. That means oil phase will separate and water phase will separate. Both solution will again get immiscible in each other. This means thermodynamically unstable upon the application of temperature. Second, biphasic liquid dosage forms of consisting of two immiscible liquids, as I mentioned earlier, that water and oil are two immiscible liquids. They are dispersed with the help of an emulsifying agent. So, emulsifying agents are the surface active agents which act on the interfacial tension of two immiscible liquids and allow them to mix together. So, with the help of emulsifying agent, two immiscible liquids are mixed together. So, emulsion, as we said, biphasic liquid dosage form, it consists of two phases. The first phase is the internal phase, or also known as the dispersed phase or the discontinuous phase. Phase 2 is the external phase, dispersion, or also known as continuous phase. There is a criteria that to form an emulsion, the continuous phase, or you can say the dispersion phase, the liquid present in the bulk. Okay, so that kind of phase should not less than 74% of total emulsion. Okay, so that means up to 26% of dispersed phase is allowed to make an emulsion. So when phase 1 is homogeneously distributed in phase 2, forming fine globules size ranging from 0.1 to 100 micrometer, an emulsion is formed. So how an emulsion is formed? When the two immiscible liquid, the dispersed phase, is added to the continuous phase, with the help of emulsifying agents, the surface tension is reduced significantly, which allow two liquids to, upon agitation or some kind of mechanical stress, the dispersed phase broke down into small globules, very small fine particles of immiscible liquids that are homogeneously distributed in the emulsion. So the smaller the particle, the clearer the emulsion will be. The larger the particle, the turbid the emulsion will be. Which means, जितना globule size बड़ा होता जाएगा, उतना ही emulsion opaque या turbid होता जाएगा, milky type appearance आएगी. जबकि जितना particle छोटा होता जाएगा, नैनोमीटर, जितना small particle, नैनोमीटर्स में जितना छोटा particle करते जाएंगे, उतना ही emulsion एक clear solution की तरह बनता जाएगा. So, in order to find out what kind of emulsion is it, on the basis of its appearance, if it is milky, then the globule particle size should be large, and if it is clear, the globule particle size should be very small. Okay, so to the next slide, the classification of emulsion on the basis of dispersed phase. As we earlier mentioned, there are two phases, the dispersed and the dispersion phase. So first classification is based on the dispersed phase. Dispersed phase, according to dispersed phase, water in oil type emulsion. W by O means water in oil. An example is cold cream. In this type of phase, that is, water is dispersed in oil. So the cold creams, as we know, we use cold creams in the time of winter, because at the winter the relative humidity is low, air is thinner. So atmosphere absorbs moisture from our skin, making it dry and letting it crack. So in that time we use oil to moisturize our skin. So cold creams will be prepared, as we say, as you can see here, water in oil. That means water is in smaller quantity, oil is in bulk quantity. So when the water is added to the oil, the cold cream is formed to provide you moisture for the long time. Similarly, although in the summer times, as we know, relative humidity is high and our skin is already emitting oil, which is not oil, actually it is sebum. So in the summer times we use creams that rapidly vanish from the skin. They do not leave the oily part or oil on the skin. So those creams are vanishing cream. For example, Fair and Lovely cream. These are the vanishing creams. So these type of emulsions are oil in water type. As you can say that they are distinguished by their name. First one is water in oil. So the dispersion phase is oil, that oil is present in large amount, it is cold cream. When the oil is present in less amount, it is vanishing cream. However, I want to add another example of oil in water type, that is milk. Okay, the milk is an emulsion which is oil in water type emulsion. कभी milk जब आप फाड़ोगे acid डाल के, होता क्या है? How milk is constituted? Milk is a natural emulsion. So milk, as I told you that milk is oil in water type emulsion, that means oil is in lesser amount and water is in larger amount. So when milk is formed, the protein act as emulsifying agents. The proteins are those substances which allow oil to mix with the water to form milk. So when we add citric acid or any other acetic acid like vinegar, we used to when we prepare cheese from the milk, we add vinegar to it, which allows the emulsion to break down. The oily part is separated from the water type. So why? Because acids led the protein precipitation. Acid cause proteins to precipitate. If the emulsifying agent is precipitated, if we break down the emulsifying agent, snatch the activity of its surface activity of emulsifier, the emulsion will definitely crack. So how milk कैसे फटता है? Acid डालने से, क्योंकि protein precipitates हो जाती है. The proteins are responsible to form the emulsion of the milk. So if protein lost their property, emulsion will crack. So that's why acid डालने की वजह से दूध फट जाता है. Okay, so oil and water type emulsions are vanishing cream and milk. However, there are some examples. There are some complex emulsions also formed, that is oil in water in oil type emulsions and water in oil in water type emulsions. They are very complex emulsions, are less oftenly used. However, in some cases, in some medications, when we use two different kind of medications, for example, you can say multivitamin emulsion. The A, D, E, K are oil soluble vitamins and C and B are the water soluble vitamins. If we have to deliver all the vitamins together, we will use the complex emulsion type, because in oil A, D, E, K were soluble and in water B and C were soluble. These two emulsions will again dispersed in the third phase to form a large quantity of emulsion. So in such scenarios, complex emulsions were prepared. Okay. So next is on the basis of globule size. There are two bases for classifying the emulsion. Second is on the basis of globule size, in which macro emulsions were formed, in which the globule size is from 0.1 to 10 micrometer. Means macro means larger. So when the globule size are larger, then macro emulsions are formed, and the criteria to form macro emulsion is the particle size, that is 0.1 to 10 micrometer. And these type of the micro emulsions जिनमें globule size बड़ा होता है, they are kinetically stable. Although in case of micro emulsions in which the globule size is further reduced to 10 to 200 nanometer, these type of micro emulsions are thermodynamically stable. Okay, that means micro emulsions are more stable to changes in temperature. So up to the next slide, the emulsifying agents. So as we discussed earlier, in the milk, the proteins are the emulsifying agents. Similarly, various emulsifying agents were, some synthetic and some natural based emulsifying agents were used to prepare emulsions of different kind of drugs. There are pharmaceutical emulsions, there are cosmetic emulsions, like I have discussed in the example that cold cream, vanishing creams are the cosmetic emulsions. So these are all prepared with the help of emulsifying agents. In order to mix two immiscible liquid, there should be a requirement of surface active phenomena, and those substances which causes the surface interfacial tension reduce, causing the two immiscible liquid to mix together, are called emulsifying agents. Okay, so emulsifying agents are also known as surfactants. However, they are collectively, the term for them is the surface active agents. All agents are acting on the surface of two different immiscible liquids. When a surface active agent is acting on interface of two liquids, it's called an emulsifier. When a surface active agent is acting on a solid and a liquid interface, it's called a surfactant. So according to that, the name is classified, although they are all come in the category of surface active agents. So an emulsifier is a compound or substance that acts as stabilizer for emulsion, preventing liquid from ordinary don't mix from separating. So emulsifier, as the word comes from the Latin word means to milk. So the emulsifiers came from the Latin word which means to milk. So as we know, the milk is the natural emulsion, the first emulsion we have I think encountered in the mankind. So the Latin term given to preparing an emulsion with the help of emulsifier is to milk. The emulsifier is in Latin is known as to milk. Okay, so as what are emulsifying agents? These are the surface active agents which reduce the interfacial tension and allow two immiscible liquids to disperse in each other or to mix with each other. Now up to the next part, how an emulsifier work. First, as I said, they act on the interfacial tension. They reduce the interfacial tension, allow the two mixing of liquids. Now, how they act on the interfacial tension, in which the first part is the mono and multipolar layer formation on the interface. The emulsifying agents are generally like the proteins in the milk. They have large molecular structure having both hydrophilic moieties and lipophilic moieties. So these are the large molecular structure globules or around the interface of two immiscible liquids. These molecular layers will allow the mixing of two different solutions and reducing the interfacial tension. Okay, so in the presence of molecules in the interface allow an emulsion to get stabilized or to get the dispersed phase in the dispersion phase in the suspended form. Next is the formation of solid particulate film. This means there are some colloidal solid particulates or emulsifying agents, that those agents which are forming a small solid particles or very fine small particles were accumulated on the surface of the immiscible liquid. When we agitate the two miscible liquids, the dispersed phase which is present in lesser amount will disperse in small particles in the dispersion phase present in the bulk amount. So जब छोटे-छोटे ग्लोब्यूल्स फॉर्म हो जाते हैं एजिटेशन की वजह से, तो फिर जब हम emulsifier डालते हैं, इन केस ऑफ द सॉलिड पार्टिकुलेट फिल्म, द कोलॉइडल और द फाइन पार्टिकल्स व्हिच आर एक्ट एज emulsifying एजेंट, वो ग्लोब्यूल्स की सरफेस पे एक्यूमुलेट हो जाते हैं. Okay, so accumulation of small fine particles, solid particles or emulsifying agents on the surface of the dispersed phase of the globules causes which would result in the stabilization of emulsion. So surface पे जब वो solid particulates आ जाएंगे, they act as an barrier which will reduce the mixing of two globules. मतलब जब वो इंटरफेस पे सॉलिड पार्टिकुलेट्स जमा हो जाएंगे तो वो एक दूसरे ग्लोब्यूल्स को आपस में जुड़ने नहीं देंगे, which will cause the stabilization emulsion. If the two globules mix together, then slowly all globules will mix together and phase separation occurs. So phase separation को अवॉइड करने के लिए जो इंटरफेशियल टेंशन है, छोटे छोटे ग्लोब्यूल्स बन गए, उनकी इंटरफेशियल टेंशन को रिड्यूस किया जाता है ताकि वो आपस में मिक्सअप ना हो पाए और डिस्पर्स रहे. So by this, these are the two mechanisms. First, forming a multimolecular layer. Second, deposition of solid particulate around the interface. Okay. There are some examples. There are ionic surfactants. जैसे ionic surfactants are those surfactants which consist of ions, which means polar surfactants, which having different ion, positively and negatively charged ions. Both anionic and cationic surfactants are come under the ionic surfactants. Because of their polarity and the substances or the ions present in those ions will ultimately cause an electrostatic stability. That means there are electrostatic and repulsive forces between the globules. So the electrostatic forces allow them to get rest in the dispersed phase. The electrostatic forces जो है वो globules को आपस में mix नहीं होने देती हैं. तो ये आयनिक सर्फेक्टेंट का काम होता है। वो पोलैरिटी जो सरफेस है ग्लोब्यूल की, उस सरफेस पे जैसे मॉलिक्यूलर लेयर बना देते हैं, दोज मॉलिक्यूल्स आर इलेक्ट्रिकली चार्ज्ड और यू कैन से पोलर। सो बिकॉज ऑफ द पोलैरिटी the formation of an polar molecular layer on a globule will cause electrostatic repulsion between the globules, which restrict them to mix together. अगर वो mix हो गए then they will lead to the phase separation. तो phase separation को avoid करने के लिए आयनिक सर्फेक्टेंट्स जो होते हैं वो electrostatic stabilization provide करते हैं because of the presence of polarity in them. Another type is non-ionic surfactants. Those are the polar surfactants. That means जिनके पास polarity नहीं होती है, charged positively or negatively charged present नहीं होते हैं. They are generally the long chains of aliphatic carbon chains. Which means मतलब जितने कार्बन ऐड करते जाओ, those substances are polar in nature. जितने आप हेटेरो एटम्स या इलेक्ट्रोनेगेटिव एटम ऐड करते जाओ, फॉर एग्जांपल ऑक्सीजन, नाइट्रोजन, क्लोरीन, ब्रोमीन, these atoms will provide electrostatic charge or cause a polarity in any molecule. And non-ionic surfactants are generally hydrocarbons. So large molecules of hydrocarbons act as polar or non-ionic surfactants. They provide the steric stability, which means when they accumulate, they provide the Brownian motion for the globules. That means Brownian motion or weak van der Waals forces or weak other kind of forces, repulsive forces, because of the lipophilicity of these non-ionic surfactants, they cause the steric stability. Steric is the structural stability of the compound. The electrostatic stabilization means repulsive forces because of the polarity, and steric means the structure is stabilized because of the intermolecular layer of non-polar molecules in around the globules of surfactants. So this is students clear है आपको ये टॉपिक, हाउ ए emulsifier works? Any questions?
No sir, thanks.
So moving on to the next slide, types of emulsion, types of emulsifiers. So next is the as we discussed various process of emulsifying, how an emulsifier stabilize an emulsion. There are different type of emulsifiers. For example, anionic emulsifier. These are the examples of the polar type or ionic emulsifiers. First one is anionic. That have anionic means negatively charged ions. Those emulsifying agents which consist of negatively charged ion and impart a potential of emulsion to the imparts a negative potential to emulsion. One more thing I want to add in this topic, that when an emulsion of fine globules is formed, upon the evaluation of emulsion, we evaluate it for the potential it is carrying. So, in case of potential, the electrostatic stability is observed. कैसे? एक emulsion जब prepare होता है तो उसका हम potential देखते हैं कि किस टाइप का potential है. तो जब हमने ionic surfactant डाला होता है तो वो negative में आता है. Mini electron volts में उस potential को calculate किया जाता है. तो एक emulsion जो कि stable रहेगा, उस केस में एक जीटा पोटेंशियल नाम का इंस्ट्रूमेंट होता है, जीटा साइजर, जो साइज भी बताता है ग्लोब्यूल का और कितना चार्ज है, कितना पोटेंशियल है ग्लोब्यूल का, वो भी बताता है. उसकी इंपॉर्टेंस क्या है कि जैसा मैंने पहले भी एक्सप्लेन किया कि सिमिलर आयंस जो है वो रिपल्सिव फोर्सेस कॉज करते हैं. तो जैसे एनायनिक सर्फेक्टेंट होगा, उसका जो पोटेंशियल होगा वो नेगेटिव में होगा, मतलब 0 to -30 इलेक्ट्रॉन वोल्ट. तो अगर इमल्शन का 0 to -30 इलेक्ट्रॉन वोल्ट का पोटेंशियल है, दैट मींस इट इज स्टेबल. सो -30 इलेक्ट्रॉन वोल्ट इतना पोटेंशियल है जिसको कि हम रिपल्सिव फोर्सेस के तौर पे कैलकुलेट करते हैं कि जब ग्लोब्यूल्स हैं वो एक दूसरे से रिपेल करते रहते हैं, दे कीप ऑन रोटेटिंग इन द डिस्पर्शन फेज व्हिच कॉज ए होमोजेनिसिटी इन द डोसेज फॉर्म. ठीक है. इन केस अगर इलेक्ट्रोस्टैटिक स्टेबिलिटी नहीं है तो दे विल अट्रैक्ट टू ईच अदर, ऑपोजिट आयंस अट्रैक्ट टू ईच अदर, वो अट्रैक्ट करेंगे एंड द मिक्सिंग ऑफ ग्लोब्यूल अकर व्हिच कॉजेस द ultimate emulsion for phase separation. दोनों phase separate हो जाएंगे. So anionic emulsions, this type of emulsifiers when added to the emulsion, that emulsion will give the negative potential. So an example of anionic surfactants are sodium stearate, potassium chlorate. SLS stands for sodium lauryl sulfate. It is also used as detergent in the daily household keepings. Next one is the cationic emulsion. Similarly as the anionic gives the negatively potential, cationic gives the पॉजिटिव पोटेंशियल. तो इमल्शन जो कि कैटायनिक इमल्सिफायर से बनता है, those globules are positively in charge and have a positive potential, and similar globules having the similar potential will repel each other. So ये repulsive forces उन्हें dispersion phase में घुमाती रहती है, which do not allow them to settle down or mixing together because of these electrostatic forces. This means the electrostatic stabilization. Okay, so these are the ionic surfactants. Next is the non-ionic surfactants, or you could say the polar surfactants, in which lecithin is a form. Lecithin is an example of natural emulsion. Lecithin is a kind of emulsion which is present in the nature and extracted from various sources like plant. Plant also gives the lecithin. Next is the twins. Twins are the water-soluble non-polar surfactant emulsifiers, and spans are the oil-soluble. Spans are the oil-soluble emulsifiers, non-polar emulsifiers. Third one is the amphiphilic solid like silica and clays. Clays में example bentonite. Bentonite जैसे ये solid particulates, जैसे मैंने work of emulsifiers में कि how emulsifiers work, I have explained that at the interface of the two liquid, जो solid particles are, they accumulate on the interface and not allowing two globules to mix together. This is the example of that kind of solid particulates, colloidal solutions or fine particles, solid particles. For example, clay, bentonite जब एक emulsion में डाला जाता है, जब globules उसमें agitation की वजह से globules create होते हैं emulsion में, तो globules के interface पे bentonite deposit हो जाता है, जिसकी वजह से फिर वो दो globules को आपस में मिलने से रोकता है. It forms a protective covering type layer onto the globules. Now come to the twins and spans. Twins or spans जो है most commonly used emulsifier है. It is used to prepare a large number of emulsifiers in the laboratory practices in small scale preparations. So twins are the polyoxylene methylene sorbitate mono salts of lauric acid, palmitic acid, stearic acid and oleic acid. So when this molecule is reacted with these acids, they form twins. So they are classified on the basis of molecular structure. That, for example, lauride is given the number 20, palmitate is 40, stearic is 60 and oleic is 80. So in case if you have asked the question there, what is twin 20, you can write polyoxylene methylene sorbitant mono lauride. In case of twin 80, it is oleate, sorbitant mono oleate. Similar is the case with the span. Span is sorbitant mono laureate, sorbitant mono palmitate, sorbitant mono stearate, mono oleate. So span 20 is laureate, similarly span 80 is oleate. So LPSO, it is the term you should remember, that LPSO stands for laureate, palmitate, stearate and oleate. So according to twin 20, 40, 60, 80, these represent the reactions of twins with the respective acid. If it is twin 20, then it is reacted with lauric acid to form laureate salt. Similar is if it is twin 60, it is reacted with the stearic acid to form stearate salt. Okay, so these are twins and spans. So in one thing I want to add in this, that twins are water soluble emulsifiers. Okay, so when you have to prepare a water soluble emulsion like water in oil type emulsion, you use the water soluble emulsifiers, oil in water type, because the dispersion phase, the bulk phase is water, so we use water soluble twins. And when we have to prepare water in oil type, then which means the bulk phase is oil, then we use this topic that twins and spans, how they are used when we are preparing oil in water type emulsion, which means water is in bulk phase, we use water soluble twins emulsion, and when we are preparing water in oil type emulsion, that means oil is in bulk phase, we will be using span, that are oil soluble emulsifiers. So HLB, what is an HLB scale? HLB scale gives the amount of or the size and strength of the hydrophilic and lipophilic moieties present in an emulsifier. Hydrophilic moieties are generally those substances or those elements or those atoms which are more water loving. Okay? So in case to become a surface active agent, one should have a criteria that it should be hydrophilic and lipophilic both in nature. Okay, so if in order to become any compound a surfactant or surface active agent, it should have hydrophilic and lipophilic moieties. So how they are observed? According to the HLB scale. So it is dependent upon the size and strength of hydrophilic and lipophilic moieties. more the strength of these moieties, higher will be the HLB scale value. So according to this scale value, 1 to 3, the substances that come in the range of HLB scale 1 to 3 are anti-foaming agents, those agents which reduce the foaming. 3 to 8 are water in oil type emulsifiers. The surface active agents come under the range of 3 to 8 in HLB scale are water in oil type emulsifiers. 7 to 9 are surfactants, 10 to 16 are oil in water type emulsifiers, 13 to 16 are detergents, and 15 to 18 are solubilizers. Now next is the emulsion preparations. How emulsions are prepared. In laboratory practice or in small scale preparation practice, there are 3 methods of preparation, in which first one is the dry gum method. In this dry gum method, oil and gum are triturated together with a small amount of water in a mortar vessel. Upon mixing, it forms a very consistent, very viscous paste-like consistency is occurred. So in this type of consistency, small air bubbles burst when we mix them together, and their bursting of the small bubbles cause clicking sound. When this clicking sound is starting to appear in that kind of mixture, when we mixing it, it means primary emulsion has been prepared. So when the primary emulsion is prepared, it is then diluted with the dispersion phase, the bulk phase, to prepare the final emulsion. So in case of dry gum method, oil and gum and less amount of water is used, while in case of wet gum method, large quantity of water is used in respect to oil. Gum and water, 2 parts of water. In gum is triturated in 2 parts of water with small amount of oil, which give a mucilage type consistency. एक mucilage type consistency बनती है. उसका जब mucilage type consistency is prepared, then it means primary emulsion has been prepared. This primary emulsion is then diluted with the dispersion phase to give the final emulsion. Third method is the bottle method, and it is the most simple method in which all ingredients, including 2 immiscible liquids and emulsifiers, are added to a bottle and shaken vigorously. Will produce the emulsion. In large scale preparation, like in industry practice, when emulsion is prepared in bulk volumes, then homogenization is used. Next is the composition of primary emulsion. When we are preparing emulsions, primary emulsion using gum like acacia gum and oils, the oils are classified in 4 parts, that is fixed oil, mineral oil, volatile oil, and oleoresins. In case of fixed oils, the concentration of oil in primary emulsion is 4:2:1. That means 4 parts of oil, 2 parts of water, and 1 part of gum is triturated together. As I mentioned in the dry scale method, 4 parts of oil is triturated with gum, 1 part, and 2 parts of water is added until the clicking sound is formed. The clicking sound confirms the preparation of primary emulsion. In case of fixed oil, 4 parts of fixed oil is used. For example, arachis oil, almond oil, castor oil, these are the fixed oil, example of fixed oil. In these types of oil are added in 4 parts. While liquid paraffin is an example of mineral oil. In case of mineral oil, 3 parts is added while the water and gum are similar in the quantity, 2 parts of water, 1 part of gum. In case of volatile oil, further the concentration of oil is reduced to prepare the emulsion. Examples of volatile oil are cinnamon, peppermint, turpentine oil. These oils are added only 2 parts equivalent to water. 2 parts of oil, volatile oil, 2 parts of water, and 1 part of gum. In case of oleoresin, the concentration is further reduced to 1 part just. 1 part of resin, 2 part of water, and 1 part of gum is triturated together to form primary emulsion and then diluted suitably with the dispersion phase to form primary emulsion. So in this chart, you have to just remember the concentration that fixed oil is used in 4 part, mineral oil is further reduced to 3 part, volatile is reduced to 2 part just, and oleoresin is added in just 1 part. So moving on to the instability of emulsions, first is the flocculation. Flocculation is the process of forming a cluster or loose aggregates of the globules. In the emulsion, globules are homogeneously distributed in the dispersion phase. When in flocculation, they form clusters due to the weak forces, and it is a reversible process. That means when these clusters are formed upon agitation or mixing or shaking the emulsion, these globules were again dispersed into fine particles. While the second instability is the coalescence. In case of coalescence, despite of loose aggregates, as we discussed in flocculation, the globules merge together to form larger globules, which is irreversible. Upon agitation, the globule will not break and cause slowly the globules mix together to form ultimately causing the phase to separate. Next is the creaming. As we earlier discussed in the creaming, if upward creaming occurs, the emulsion is oil in water type, for example milk. If downward creaming occurs, the emulsion is water in oil type emulsions. Creaming is the next. After coalescence, creaming is the next phase of cracking the emulsion or instability in emulsion, while the cracking and breaking is the final phase in which complete separation of phases occur. Because when globules, in case of coalescence, globules mix together to form larger globules, these globules will then cause creaming of solution, and after creaming, completely the oil phase and water phase will separate, causing the emulsion to break down. In another case of instability is encountered in the emulsion, that is phase inversion, which is characterized by the conversion of emulsion type. For example, change of oil in water type emulsion to water in oil type and vice versa. That means water in oil type is converted into oil in water type, and similarly water in oil type is converted to oil in water type. This is characterized by the phase inversion. Now up to the last slide, that is tests of emulsions. First test is dilution test. It is very simple test. That means if you are given a solution and you have to identify it, you just add water to it. If the solution is oil in water type emulsion, then emulsion will not break. Phase separation will not happen because we are just adding the dispersion phase. But in case of water in oil type emulsion, if water is added, the phase separation occurs because of the lack of emulsifying agent. So extra water को disperse नहीं कर पाएगा emulsion because of the lower concentration of emulsifying agent. So phase separation occurs. So by the dilution test, you can easily distinguish what kind of emulsion it is. Second is the electricity conduction test. It is very simple test. It is also positive. It is only positive for oil and water type emulsions because water is a conductor of electricity. So only oil in water, which means the water is in bulk part, only this type of emulsions will conduct electricity, not water in oil type. Third is the dye test, in which water soluble dye is added to emulsion. If a uniform tint is prepared, that means oil in water type emulsion means bulk amount is water, and if water soluble dye is added to water in oil type emulsion, the globules will achieve the color while the oil will remain as it is. That confirms it is water in oil type emulsion. Similar oil soluble dyes mechanism is the same for them. Third is the creaming. As we previously discussed, if emulsion shows upward creaming, it is oil in water type emulsion. If downward creaming occurs, it is water in oil type emulsions. Again, next test is cobalt chloride test. So in this test, filter paper is first dipped in cobalt chloride solution, which is a pink color upon drying, blue color upon drying, and when this paper is added to a oil in water type emulsion, which means water is in bulk, then this cobalt chloride upon reaction with water will turns into pink color, which will confirm that the emulsion is oil in water type emulsion. If color does not change, the emulsion would be water in oil type. Last is the fluorescent test. In this test, the UV light is emulsion is observed under the UV light. The UV light is responsible to create fluorescence. Fluorescence is a phenomena of absorbing light and emitting afterwards. So when the UV light is emulsion is exposed to a UV light, only the oil is fluorescent. If the emulsion is water in oil type, the whole emulsion will fluorescent, and if emulsion is oil in water type, only the globules will fluorescent, which gives a spotty pattern. Okay, so these are the tests to identify what type of emulsion is it. Okay, clear, students?
Yes, sir.
Okay, thank you, class.